The lesson topic for this video is solving quadratics by undoing with imaginary numbers. So this lesson is going to look a lot like the previous lesson about undoing using the PEMDAS steps, okay? But we're going to run into a situation where we have a negative under the square root. Now if you look at these four examples, square root of 49, square root of 114, the square root of negative 36, and the square root of negative 11 should make you think a little bit here, okay? Because if you think about what square root means, it means what number times itself gives you the number under the root. So what number times itself gives us 49? Well, the answer there is 7, because 7 times itself, 7 squared, equals 49. Okay? So 7. Now the next one, the square root of 114, well, square root of 114 is somewhere between 10 and 11, because if you think about 10 squared is 100, and 11 squared is 121, so we know 114 exists somewhere in here. So if we use our calculator, we will find that it is 10.677. If I multiply 10.667 by itself, I will get as close as possible to the square root of 114, or I will get the closest I can to 114. So that's that one. Whoops. All right, now the square root of negative 36. Well, we know that 6 squared is 36. So you might be thinking, oh, well, then it's negative 6. Negative 6, when squared, if we take that whole thing and square it, whether in our brains or with our calculator, make sure you have those parentheses if you do use your calculator, will be also 36, not negative, because it would be a negative times a negative, which becomes a positive. So this is where we run into an issue, and the issue is you can't square root a negative number. Which is why mathematicians of the past decided that they were going to make up something called the imaginary number system. And in the imaginary number system, this is kind of an important thing to write down here, we are going to use the letter I to represent the square root of negative 1. Okay? If I were to break this down into the square root of negative 1 times the square root of 36, well, the square root of negative 1, we just learned, is the lowercase cursive I. So I'm going to use the lowercase cursive I. And we know the square root of 36 is 6. So it would be I times 6. The best way to write this, by the way, would be 6i. Usually we put the number in front of something that is similar to a variable, right? So 6i. That's how we use the imaginary number system. We just put a little lowercase cursive I on there to represent that we are in a negative square root situation. So how about this one? Square root of negative 11. Well, again, we can break this down into the square root of negative 1 times the square root of 11. Well, the square root of negative 1 we learned is I, and the square root of 11, well, it doesn't break down into a whole number, so we can just leave it as the square root of 11. And that is what we get for that one. Let's see how this is applied to our solving quadratics by undoing. All right, so we're going to take a look at this example right here. It says solve algebraically, given y equals 3 times the quantity x plus 2 squared plus 5. We're trying to find y when x equals 8 and find x when y equals 2. So, first of all, I'd like to remind you that if we know the value of x, which is what we know right here, we are going to do this problem by using the trace function on our graphing calculator. So again, a quick reminder, we're going to go into y equals or y1 equals or whatever on our calculator, and we're going to type in 3 times x plus 2 squared plus 5. Again, do not put this number 8 in here when we're typing it in. Just type this in for y1. After you graph it, all we need to do is hit trace and then the number 8 in this case. All right, when you do that, you should get 305. So y equals 305. So when x is 8, y is 305. Again, we could have done this by putting that 8 in here, doing the math ourselves using the order of operations, but we're allowing you to do this on your graph for two reasons. A, it's a little quicker and more accurate, and then B, to continue practicing our functions with our calculator. All right, Now the one that you have to do by hand is when you know your value for y. All right, so we know that y equals 2 right here. So we're going to go ahead and put that in for the y right here, and we're going to solve for x. So 2 equals 3 times x plus 2 squared plus 5. Remember, we are using PEMDAS backwards, which is why we call it solving by undoing. We're undoing the order of operations to solve. So I'm going to start by subtracting 5 from both sides, because we're doing addition and subtraction first, and not the one that's in the parentheses, because that would be last, the plus 2. So subtracting 5 from both sides, we have 2 minus 5, which is negative 3, equals 3 times x plus 2 squared. Now we are going to divide both sides by 3. We're doing our multiplication and division next. We're going to divide by 3. Again, do not distribute. Do not distribute. We're going to divide by 3. This will be negative 1 equals, these cancel, 1 over 1 there, and we get x plus 2 squared. Next, we're on to our exponent. To undo exponents, in this case a squared, we need to square root it, and we need to square root this side. The square root and the square cancel out over on the right, so we're left with x plus 2 equals, and it's the square root of negative 1. Now, here is where we need to stop for a second and realize that this is different from our previous lesson. The square root of negative 1, if you try to do it on your calculator, will give you an error. It'll say something about imaginary numbers, most likely. So what do? Well, first of all, what we have to remember right off the bat is that we're going to put a plus or minus, just like we did on the previous lesson, because when we square root both sides, we need a plus or minus, and then we are going to simplify the square root of negative 1. If we think about that again, off to the side here, square root of negative 1, we actually learned on the previous screen that the square root of negative 1 is I. Now, if this number was something different, we would want to break it down and talk about it, and we'll do that on the next example, but we know that the square root of negative 1 is simply I. So I'm going to put an I right here. Okay? Maybe I will do that with the correct color. Here we go. So, I. Now, we're not done solving this, but there is a little hint I'd like to give you. Once you get the square root of a negative and you deal with, you see a square root of a negative, I do not want you to use your calculator ever again for computing anything. It's just kind of a reminder, because it's hard to explain without seeing some examples, but people try to continue doing some calculating, which does not work. So as soon as you see a square root of a negative, flip your calculator upside down and say, I'm not going to use this anymore. You're not going to use it. Okay? But anyway, so we'll see more of that later. At this point, though, we do need to subtract 2 from both sides of the equal sign, because we need to get x alone. All right, and just like I did again on a previous lesson, so those cancel out, and now we have x equals positive I minus 2, and x equals negative I minus 2. And that's it. That is our answer for this example. Plus positive I minus 2 and negative I minus 2, and since I is just a variable we use to represent the square root of negative 1, there's nothing else we can do with this solution. All right, so one last example here. We have f of x equals negative 3 times the quantity x minus 3 squared minus 15. We're trying to find f of 3 and find x when f of x equals negative 4. So to make this a little bit quicker on our lesson video, I'm going to remind you to make sure you can do this with your graphing calculator. So go ahead, plug this into y1, and then find f of 3, remembering that f of x has been changed into f of 3, which means that x equals 3. So that's how we use, or when we use, trace. So go ahead and do that and check your answer. Okay, so if you were graphing with your standard window on your graphing calculator, I just want to point out that you might not have seen the parabola. Well, you wouldn't if you were in a standard window. Now, you might have been in a bigger window with a different x max and min and y max and min. If you hunted down the parabola and you found it, that's fine. If you didn't and you noticed that if you hit trace and 3, and you did not find the parabola, you still actually come up with your answer, and it's y equals negative 15. If you have questions on that, go ahead and ask me in class and I can clear that up. All right, so let's go ahead and try this other one. Find x when f of x equals negative 4. Well, we're obviously going to put negative 4 in for f of x. Again, another name for y. Here's f of x right here. So we're going to go ahead and type negative 4 equals negative 3 times the quantity x minus 3 squared minus 15. All right, so again, using the reverse of PEMDAS, undoing. Okay, we are going to start with addition and subtraction and undo them. So we're going to undo the subtraction of 15 by adding 15 to both sides. We're going to get 11 equals negative 3 times x minus 3 quantity squared, and those cancel. After we do our addition and subtraction, we're going to do our multiplication or division. In this case, we need to divide by the negative 3. Again, there is multiplication in between right here, if you want to think of that as a dot. Therefore, we need to divide by negative 3 on both sides. The negative 3's cancel. And we get, let's see here, negative 3.667. We do want to round to 3 decimal places when we do these, equals x minus 3 squared. Now, we have to undo our exponent next. The squared tells me I need to undo it, which is a square root. Square root both sides, like so. And we know that when we square root both sides, we're going to get a plus or minus answer right here. So we have plus or minus the square root of 3.667. Now, this is where I mentioned on the previous screen I would come off to the side and talk about this briefly. So here's negative 3.667 being square rooted, and you can think about this as being the square root of negative 1 times the square root of 3.667. Okay? Well, that means we have this is I, and then we have the square root of 3.667. And I am just fine with you leaving it in this form. Remember a minute ago, again on the previous lesson, or previous example, I said once you get a negative under the square root, turn your calculator over. We are not going to square root the 3.667. Okay? So again, once you get to a negative under a square root, calculators are no longer used. So we're going to use the I, we have to write the I, and then the square root of 3.667. So that's what I'm going to write right here. I'm going to write plus or minus I root 3.667 equals x minus 3. Now, to solve this completely, we need to get x alone, so I'm going to add 3 to this side, which means I need to add 3 to this side. Again, the important reason that we don't want your calculators in your hand anymore is right here. People believe that they should combine this with the 3, or I don't know how, but the I with the 3. Somehow people want to combine all of this together with computation, okay? We are not going to. We are going to rewrite it together, okay? So again, we're writing x equals, we've got positive I root 3.667 plus 3. And we've got negative I 3.667 plus 3. And that's it. Again, a lot of times if people take this and square root the the square root of 3.667, if they square root it, they get a number that then they think they can add with a 3, and they can't. So the reason I say once you get that negative under the square root, do not worry about computing any longer. We're just going to have this kind of long, crazy answer. So the imaginary number system, the main thing we're going to do is just simplify a negative under the square root into an I situation, and otherwise it's just going to be left in this format.